Hello, myself Naveen Kumar Saini in the course of Electromagnetic Field Theory, code BEE301. Today we are going to discuss about the coordinate system and the transformation. So coordinate system, which is defined as in the space which can be suitable for representing the coordinates. So here we will discuss about the orthogonal coordinate system. So in which what is the definition of the orthogonal coordinate system? That is all the axes are perpendicular to each other, or we can say all the basis functions are orthogonal to each other. So we call it as the orthogonal systems. So in our course we will concentrate on these three coordinate systems. First one is the Cartesian coordinate, cylindrical, and the spherical coordinate system. Second type of coordinate systems are non-orthogonal coordinate system. So the definition, if this one is that the coordinates are not mutually perpendicular to each other. It means all the basis functions which is the dot products will not be 0. Right? This is the basic definition of the non-orthogonal coordinate system. So let's start. First is the Cartesian coordinate system, in which there are two things which we have to take care about this thing. First one is the variables. The first thing is which we will concentrate, that is the variables. Okay, and second one will be the component. In all the coordinate systems we will discuss about these 2 points, variables and the coordinates. So in the Cartesian coordinate system, they are the variables. These are the x, y, z. So these are the variables, and the components, these components will be of the vectors. So here the components will be ax, ay, and az. So we will focus on to this. So first thing is which we have to take care about the variables. So we will come to know about what is the range of the variables. The range of the variables: x range, that is the minus infinite to plus infinite, y minus infinite to plus, and the z is also plus minus infinite to plus infinite. So we are very much aware about this basic coordinate system, that is Cartesian coordinate system, and we also call it as the rectangular coordinate system. So second is the first one is the variable, and second one is the component. So as I said, components will be of the vectors. The vector A is in the Cartesian coordinate system is representing as ax, ay, az, or in vector form we write it as the ax, ax, ay, ay, and az, az. So these ax, ay, az are the components, and the direction of these components are representing like this: ax in the direction of ax, ay in the direction of ay, and az in the direction of unit vector az. Right? So in the diagram we can also look at it that P is the point. Okay. So this P point can be represented as the x in this direction, and then y, and then z. So these are very basic thing which each one of you are very much aware, right? Variable, and second one is the vector or the component. So this in the case of the cylindrical coordinate system, the variables are rho, phi, z. So in that, what is a rho, what is a phi and z? So rho is the radial distance from the z-axis. So we are very much aware that if this one is the cylinder, so what is the structure of the cylinder is like this, and the rho is what? This is the radius of the cylinder, right? So this can be represented in that way. Then second one is the phi. So phi is what? Phi is nothing but this is the phi from the x-axis, and z is very much known, that is the z in the z-axis. So what these guys are representing? This is representing the point P. So in this case the point P will be your rho, phi, and z, right? So rho is the radius, phi is the angle from the, or we can say this is the horizontal angle from the x-axis, right? Or from the x-axis, or from the xz plane. Okay, and z is the in this way. Second is the range of these variables. Range of rho is from 0 to infinite, phi is 0 say 2 pi, and z is minus infinite say to plus infinite. So these are the range of the variables. Corresponding to that, we have the components for that. Components will be a rho, a phi, a z, and in the vector form we represent it as the a rho into a rho. So this is the component and this is the unit vector. This is the component, this is the unit vector, and this is the component and this one is the unit vector, right? So in this, if we want to find the magnitude of this vector, so this magnitude we can write it like this, right? So this square root and a rho square plus a phi square plus a z square. And some of the properties of the unit vector is there, that a rho with the a rho will be equal to 1, a phi with the a phi will be equal to 1, a z dot a z equal to 1. Because these are the orthogonal coordinate system. So in that case, as I said, orthogonal coordinate systems are what? Where the unit vectors are perpendicular to each other. So that is why the dot product will be 0. Okay, dot product with the self will be 1 and dot product with the other axis will be 0. Okay, so next is the cross product. Cross product is that a rho cross a phi is equal to a z, a phi cross a z is equal to a rho, and a z cross a rho is equal to a phi. So we can understand this one in this just like in the previous case. If we talk about the Cartesian coordinate system, so in that case the ax cross ax, similarly ay dot ay and az dot az will be equal to 1. Ax dot ay, ay dot az, az dot ax will be equal to 0, right? So similarly we are writing for the case of the for this cylindrical coordinate system. Okay, and in the case of Cartesian coordinate system, again the cross product we can find as the ax cross ay is equal to az, ay cross az is equal to ax, and az cross ax is equal to ay. Okay, so these all are the properties. This is the case of the Cartesian coordinate, and similarly we wrote for the cylindrical coordinate system, right? So if we represent in the terms of transformation, so the point, the P point will be xyz, and the cylindrical coordinate system point P point will be rho phi z. So both are equal, but how it means this is a transformation from Cartesian coordinate to cylindrical coordinate. If this one is equivalent to this one, then in that case this reverse order is the transformation from cylindrical coordinate to Cartesian coordinate system. So here we in the diagram, by the diagram we can understand this point. Same P point is here, and we represented the x, y and z. These are x, y and z. Rho is the radius of the cylinder, phi is the radius, this is the angle from the x-axis, and z is same as the before, this one, right? So now we are transforming Cartesian coordinate to cylindrical coordinate system, right? It means in the what we have given, it is given the x, y, z is given, and we have to calculate the rho phi z, and it means cylindrical coordinate system. So first one is the rho, right? So we have written the rho here. So if we find the rho is what? Rho is nothing but this is the resultant of x and y, right? So in this way we can write as the for example I am writing rho is in the direction of a rho, right? So we can write a rho is equal to, this is the resultant of x and y, so we can write it as the x ax plus y ay, right? Rho is equal to x in the direction of ax, y in the direction of ay, right? So when we take the magnitude of rho, then in that case when we take the magnitude, what is the value? Then rho will be equal to under root of x square plus y square. So same thing is written here. Rho is what? X square plus y square under root. Similarly, we can find the value of phi. Phi is what? Phi is this one, and this is on the horizontal angle. If this one is the horizontal angle, what is the meaning of this? It means this angle is on the plane xy plane. So this angle is on the xy plane. When this one is the xy plane, so we can find the value of phi. Phi is what? This is the y, this is the x, right? This is the y and this is the x. Then phi will be what? This will be tan inverse of y upon x, right? So in this way, we can find the value of, we can find the value of phi. Phi is tan inverse of y upon x. And z is same as the Cartesian coordinate system. So this is that is why we say this is the transformation from Cartesian coordinate system to the cylindrical coordinate system. Means in the left hand side, we have to write the variable for the cylindrical coordinate system. In the right hand side will be the function of the x, y and z. In the reverse order, if we want to transform, so this is a transformation like this. So if we write the transformation from rho phi z, we have to transform to point x, y, z. So it means in the left hand side we have to write the x, y, z, and in the right hand side we have to take the function of the rho, phi and z. So how we can find it? Here we can see, means if we are transforming this point to this point, right? So it means this is already given and we have to calculate these 3 points. So let's come to the this diagram. What is the x? X is what? X is this one. Rho is given, phi is given, means x will be what? This will be rho cos phi. This is the x. And y is what? It will be the rho sin phi. And z is same. So this is the way we are transforming the point from cylindrical coordinate to the Cartesian coordinate, and this was the point from Cartesian coordinate to the cylindrical coordinate, right? So this is the point transformation. Similar to that, we have the vector transformation. So in the vector transformation, we write it transformation of vector A from ax, ay, az to a rho, a phi, az, right? And here that the inverse of the transformation will give the transformation from cylindrical coordinate to the Cartesian coordinate system. So I hope this point is clear. So how we are getting all these things? I will give you the very brief one of the example for that, so that you can understand. If you are transforming this point, this is a Cartesian, this is a cylindrical. So we are transforming in this way. It means the left hand side we will have the a rho, a phi and az. In the right hand side we will have the ax, ay and az. So what we want this matrix. How we are getting this? So in this I will explain in this way, that cos phi, how we are getting this cos phi. So this a rho and this ax. So this is nothing but a rho dot ax, this one. And this one is what? This one is a rho dot ay. And this one is a rho dot az, right? So similarly, we can write for this one a phi, just simply multiply a phi with this. So this, what is this minus sin phi? This will be nothing but a phi dot ax. This is what? This cos phi will be a phi dot ay. And this one is a phi dot az. I hope this point is clear to all of you. Similarly, we can write for the az. So az dot ax, this one, az dot ay, this one, az dot az, this one. So this is nothing but az dot az. Okay. So let's come how we are getting this a rho dot ax is equal to cos phi. Come back. So a rho is in this direction. Sorry, this is the ax direction. This one is the a rho direction, right? So what we want to calculate? We want to calculate the a rho x dot a rho. So this is nothing but ax mod of ax mode of a rho, and angle between the ax and a phi, angle between cos of angle x and rho, right? We know this property about the how we take the dot product of two vectors. So ax, so this will be what? 1, and a rho is also 1 because this is the unit vector, magnitude of the unit vector is 1, and this theta x rho, what is this? This is the angle between ax and a rho. So angle between ax and a rho will be what? This one, phi. So we can write it as the cos of phi, right? So that is why this ax dot a rho will be equal to the cos of phi. So that is why we have written that a rho dot ax or ax dot a rho both are same thing. This is the cos phi. Similarly, we can write a rho dot ay. So we can see here a rho dot ay. So what will be this? So a rho, we can write it dot ay will be equal to a rho dot ay magnitude into cos of, what is the angle between these? 90 minus phi. 90 minus phi. So in this case, what is the resultant? It will be sine of phi. See. Okay. Now this one, a rho and az. A rho is this direction, az is this direction. What is the angle between these? 90 degree, because this is the az. Angle is 90 degree, it means the cos 90, that is 0. See, 0. Similarly, if az dot az, we know this is the 1 and the rest are zeros. So in this way, you can find this matrix by getting the angles between this one. Suppose we want to transform in the inverse order. So in that case, what will happen? This is the transformation cylindrical to Cartesian coordinate system. So what we need to do? Simply take the transpose of this matrix, right? So take the ax, ay, az in the left hand side, this one in the right hand side, and take the inverse of this matrix. So in this case, what will happen? Row will become the column and column will become the row. So that is why this kind of matrix will be observed. So this is the transformation from the Cartesian to cylindrical or cylindrical to Cartesian. So I hope this transformation matrix is clear to all of you. Okay. Next is the spherical coordinate system. So here the variables are r, theta, phi. So just what is the r? We are very much aware about the sphere. We know the sphere, that r is what? Radius of the sphere. Theta and the phi. This is very important. Phi is same as we have discussed in the cylindrical coordinate system. So in the cylindrical coordinate system, we said phi is the angle from the x-axis, right? So this is the angle from the x-axis. R is what? R is this one. What is the theta? Theta is the angle from the z-axis. Okay. So it means this P point is representing in the spherical coordinate system with the variable r, theta and phi. So this is the P point. Okay. So r is the radius of the sphere, theta is the angle from the z-axis and phi is the angle from the x-axis, right? So in this way, what this guy is representing, this is representing the projection on the xy plane to represent these variables. Now unit vectors corresponding to this r is this one. So it means the corresponding unit vector will be in this direction. Theta, because this is a vertical angle, so it means that is why for this one this will be a theta. Phi is a horizontal angle, so that is why this guy is representing like this one. Okay. R is in this direction, theta is in this direction, downward, vertical downward, and phi is the horizontal angle. So that is why these directions are representing by the unit vectors. So I hope you are very much clear about the significance of unit vector. Unit vector is nothing but this represents the direction of the scalars. Okay. So in which direction the scalar is moving, scalar quantity is moving. So for that one we represent the unit vector. Okay. Fine. So what is the range for this? Range of these variables r, theta, phi. R is what? Our range of r is from 0 to the infinite. Theta, this angle will be from this point to maximum can come to this point. So this angle is 0 to pi. Phi is a range from the x-axis. So when we are moving from this point to this point, so this angle will be 360 degree. So in this way, all the three variables has the range just like r, theta, phi, 0 to infinite, 0 to pi and 0 to 2 pi. This range also we have discussed in the cylindrical coordinate where the rho phi z was there. The range is different for that, and the x, y, z in the Cartesian coordinate system. So as I mentioned that two things we have to take care. First one is the variables and the second one is the components. So variables we have discussed. Now that components, right? So again the components are representing as the AR, A theta and A phi corresponding to the direction r theta phi. We can write the vector A for the spherical coordinate AR, A theta, this is the component, right? This capital AR, A theta and A phi, these are the components, and these components in the directions of AR, A theta and A phi, when we combine all this, then we will get this vector A, right? Vector A can be represented by the summation of these three. Now if you want the magnitude of this vector, then the vector A magnitude can be written as the square root of AR square, A theta square and A phi square. Okay. So as I mentioned, AR, A theta, A phi, these are the representation of unit vector, and these all are the properties. Again the same properties are there as we have discussed in the cylindrical coordinate system. In the spherical coordinate system, unit vectors are AR into AR, A theta and A theta, A phi dot A phi is equal to 0. And because these are the orthogonal coordinate system, it means the dot product will be 0. So AR dot A theta dot A phi dot AR will be equal to 0. Cross product AR cross A theta dot cross A phi is AR, A phi cross AR, A theta. So this is representing in the circular fashion. If we want the cross product between AR cross A theta, then in that case we will get the A phi. If we have A theta cross A phi, then the resultant will be AR. Okay. And A phi cross AR will get the resultant by A theta. Okay. If we have AR dot A phi in the reverse, then in that case we will the value minus of A theta. If we have A theta cross AR, then this value will be minus of A phi. Okay. Then if we have A phi cross A theta, in that case this will be value of minus of AR. If this one is a reverse order, then the minus sign will be there. If this one is the in this way, in that case the same value we will get with the positive sign. Okay. So this is the transformation. I will stop after this, but you have to take care about this. See, point P same in the Cartesian coordinate system, this is x, y, z. Same point P in the cylindrical coordinate rho phi z. Same point P in the spherical coordinate system r theta phi. Right. So these three are there. So we want a transformation from Cartesian to the cylindrical, spherical coordinate. So what is the meaning of that? It means we are converting x, y, z to r theta phi. So in the left hand side we will write the r, theta, and phi. So how we can write this? R. What is the r? R is the radius of the sphere. So this is the r. Direction of A is the AR, right? So this R is a resultant of X, Y and Z. So we can write it as the R AR is equal to X AX plus Y AY plus Z AZ, right? So when we take the magnitude, then the R will be equal to square root X square plus Y square plus Z square. Okay. So same thing is mentioned here. If we combine this X square plus Y square, then this is nothing but the rho square as per the cylindrical coordinate system. So we can write it like this one as well. Okay. Now if we want the phi, r, theta, phi, right? So these are three variables we have derived. Phi will be same. So this is what? Rho divided by x, right? Okay. So we can write at the theta is equal to tan inverse of rho divided by z. Okay. This one, y upon x, sorry. So this phi is what? This is the y. This is the y and this is the x. This will be same as we have discussed in the cylindrical coordinate system. Now when we talk about this theta, for that theta, we can write? This is the angle theta, this is the rho and this is the z. So theta will be what? Tan inverse rho upon z, right? So basic trigonometry, I hope you all aware about that, how you find the angles. So theta is tan inverse of rho upon z and rho is what? And rho is x square plus y square, this one. Right, this is a rho square. So when you take the rho, then it will be the square root. So this is the transformation. Similarly, we can find the transformation from spherical to Cartesian coordinate system. Right. So here x, just find it the x. X is what? X is rho cos phi, and rho we are aware rho is r sin phi, r sin theta. Right. This is the rho. This is the r. So this rho will be what? R sin theta. So when we put the value of rho r sin theta, then it will become the r x is equal to r sin theta cos phi. Similarly, y rho sin phi, y is the rho sin phi. In place of rho, we can write the r sin theta into sin phi, and the z is, this is the z, right? And this is the r, this is the theta. So in this case, the z will be r cos theta. So this is the transformation from spherical coordinate system to the Cartesian coordinate system. This is the transformation from Cartesian coordinate system to the spherical coordinate system. Similarly, we can understand about the different transformations, how we are getting the matrix. So same matrix we can find, just use your mind to solve this matrix. So what you need to find? You have to find the AR dot AX. Similarly, AR dot AY, AR dot AZ. These are the unit vectors. Okay, so what is this one? This one will be A phi dot AZ. Similarly, you can write for all. Okay, see, if I want to discuss about only this point, AR dot AX. So go back, AR dot AX. This one, AR dot AX. So when you are solving this, then you will see that the angle between this one will be sin theta and cos phi. So, right. So in this way, you can find all the variables, all the components of this matrix. Okay. So this matrix will be helpful for the solving the numericals, right? So one of the numerical is mentioned here, that how you can transform the point P into the vector. All the formulas which we have discussed already. So just try to implement this into this equation, then you will get the answers. These are very easy, but you have to remember about the matrix, how we are getting the matrix, and based on that you can solve all these kind of numericals. So I hope these things are clear to all of you. So some basic examples are mentioned and some importance are there. So if you go through it, all the numericals, if you're finding any issue, you can discuss with us. And so these are the references. The book which I referred, that is the Elements of Electromagnetics, Amano Sadeku. This is a very efficient book to understand about the coordinate systems. It will help you to go through it. Thank you very much.